So we had that quiz last class on scientific notation, and you guys are doing really well converting to and from scientific notation. I did pretty well with the powers of 10. There are a little bit of struggles yet with some of the operations. So I'm going to take just a really quick review of those operations, and then we're going to go ahead and move on to our next topic. So we have, at this point, we have 3 sets of related operations. Adding and subtracting is the first set. And when we add or subtract, remember, we need the same name. And we combine the names, or we keep the same name. When we multiply or divide, we don't need the same name. And we combine the names. So when we're looking at our scientific notation, remember that came down to the powers of 10. It really represent the name. So when we go to add, and I didn't try to fool you on anything on the quiz, when I gave you addition or subtraction, I gave you ones that had the same name already. Like 5.2 times 10 to the negative 12th plus 7.6 times 10 to the negative 12th. I gave you one that had the same power of 10 or had the same name. So we had to combine the counts. 5.2 and 7.6 make 12.8. Oops, I put my 1 in on my negative 12 there. So 12.8, and we keep that same name, 10 to the negative 12. A couple of you added the powers or combined the powers when you did addition and subtraction. So now, of course, we can't leave it like this. We do have to move that decimal point over to make it 1.28. The number got smaller, so the power is going to get bigger. What is negative 12 plus 1? Negative 11. Subtraction is the same thing, so I'm not going to do an example of that. But let's look at multiplication. 3.4 times 10 to the 9th times 5.2 times 10 to the 5th. Remember, when we multiply or divide, we don't need the same name. We're going to combine the counts. We're multiplying, so we're going to combine the counts of multiplication. So 3.4 times 5.2. It's 17.68. But we also combine the names. So 10 to the 9th times 10 to the 5th. We add powers when we multiply exponents with the same base. 9 and 5 was 14. And again, we move the decimal point. 1.768 times 10 to what power does this become? Is it 13 or 15?
15.
15, good. The number got smaller, so the power gets larger. And dividing is similar. Oh, we might have 3.24 times 10 to the negative 12th. I don't need parentheses on that. I don't want to put them in. Divided by 3.6 times 10 to the 7th. So 3.24 divided by 3.6 is 0.9 times 10 to the, now when we divide exponents with the same bases, we subtract powers. This would be negative 12 minus 7, which is negative 12 plus a negative 7. So from 0, negative 12 and negative 7 make negative 19. Now we still have to move that decimal point. This is going to be 9 times 10 to the... Now the number got larger from 0.9 up to 9, so the power gets smaller. So negative 19 minus 1 gives us Negative 20. Good. We really seem to struggle on the powers and the roots. So let's say we have 5.1 times 10 to the 9th to the power of 3. Now, just like we did with our variables, we have to take the number to a power. So 5.1 to the third power is 132.651. We haven't talked about rounding and significant digits really, so for right now we are going to leave all those digits there. And then the exponent, when we take an exponent and raise it to another power, we multiply the powers. So that's going to be 10 to the power of 9 times 3 would be 27. Now, again, we have more than one digit in front of the decimal point, so we've got to move that decimal point to make this 1.32. So 1.32651. Now, this time we move the decimal point 2 spots, so the number has to, the power has to change by 2. Is it going to get bigger or smaller? Well, this part got smaller, so the power has to get larger. 27 plus 2 makes 29. And the roots are going to work the same way. Let's say we have, I'll do a cube root, it'll make it easier. 1.728 times 10 to the 12th. Now we'll do the cubed root of it. So we have to do the cubed root of the number, 1.728. If you don't know how to do the cubed root on your calculator, a shortcut is just this, 1.728. Now you can do it to the power of 1/3. That's doing a power of 1/3 is the same as doing a cubed root. So I get 1.2. And then what do I do to the power on the exponent here when I'm doing the cubed root? The power is divided by 3. Every times 10 to the 4th. Okay, so that's just a quick review of scientific notation. Were there any other things on scientific notation you might have questions on? Okay. So make sure you are going back and doing the corrections on that quiz. As a group, you guys didn't do too bad on it, but there are definitely points to be earned back. So make sure you are getting those done. Okay, so our new topic that we're going to be moving on to is we're going to be looking at uses of variables. We've talked a little bit about some of the uses of variables. You know, we looked at them as just holding the place of an unknown number. Kind of like a general formula. And this takes on there's a couple of different ways this took on. Like a formula for area. The area of a trapezoid is this, you know, the big base plus the little base divided by 2 times h. So in this formula, those letters, those variables are just sitting there waiting for a number to be assigned out of a situation. So they're an unknown number. They're just holding that place in that formula till we know what the value of that item is in that situation. Another way it kind of materialized for us is translating. You know, we talked a couple weeks ago about if you're given a phrase, 5 times a number reduced by 8. What does that translate into? Well, 5 times the number is 5x. Reduced by 8 means we're subtracting 8 from it. We looked at these variables being used as just symbols. we were looking at manipulating those symbols. We had like 5x to the third, y to the fifth times 7x squared y, and combining those symbols. So we used them in operations. Well, today we're going to look at them in one of its final mode that we're going to be studying here, and that is an unknown value. What that means is it has a value, we just don't know what it is yet. Up here in these examples, it has no value, and we're waiting for a situation to assign a value to it. Down here, it does have a value, and we need to figure out what that value is. So what we're going to be looking at is items that look like this. Like x equals 5. And we've mentioned things that look similar to this before, but I want to make sure we're all on the same page with this. This is an equation, of course, and it's defined by this symbol here, which of course is called the equal sign. A little bit tougher, I mean, it seems like an easy thing to define, but what does the equal sign mean? It's kind of tough to define it without using the word equals. But what it means is what's on one side of it has exactly the same value as what's on the other side. In fact, we can think about it as being a balanced scale. It balances around that equal sign. What's on the left side exactly balances what's on the right side. All equations start out this way. A variable equals a number, or a number equals a variable. And then they are built from there. How do we build them? Well, we use our basic operations. We can add, we can subtract, we can multiply, we can divide, we can use powers, we can use roots. Any of our basic operations can be used to build onto these equations, to build up these equations. Now, there are other operations we haven't looked at, and we're not going to look at. We're not going to look at exponents and logarithms and stuff like that in this course. If you guys were to go on to the next semester of this course, you would get into trig functions and inverse trig functions and all that. But for right now, we're going to stick to these 6 operations. So if I wanted to build this up, one of the simplest things I could do to build up this equation would be to add something to it. So somebody pick a number between 1 and 10 for me. 7. I heard 7 was the loudest one I heard. So let's add 7 to x. So this is now, instead of just x on the left side, it's x plus 7.
Plus 7, yeah.
So now that we've added 7 there, however, this scale is going to tip unless we do what? Unless we add 7 to the other side. We have to do exactly the same thing to the other side, or the scale is going to get off balance. So 5 plus 7 is 12. So what we have here is exactly the same equation as what we had up there. They're exactly the same. We've just built pieces onto them. We've made it more complex. Now, most of the time in math, we're not asked to build equations. What we're asked to do, the command we're given, is solve an equation. Well, what solving is really asking us to do is to take it apart. And when you go to take something apart, you have to look at how it was put together. Right? If you put together a piece of furniture, or you put together a kit or whatever, you've just finished and you've just put on that last piece. When you need to take it back apart, you're going to have to take off that last piece first and go backwards. You do the opposite thing. I mean, you drive in the nail, then you pull it out. You turn the screw in going clockwise, you turn it out doing the opposite, going counterclockwise. So the same thing here. This equation was built by adding 7, what are we going to do to take it apart? Subtract 7. Very good. If we subtract 7, it takes that piece off of it, and we're left with just x there. But now, again, if we subtract 7 from one side, the scale is going to tip unless we do what?
And do it to the other side.
Do the exact same thing to the other side. So 12 minus 7 is 5. So we are back to that basic form. And when we're solving an equation, that's what we're really being asked to do, is get the equation back to that basic form. Take it apart. Well, we built this equation, so we knew how it was built. So we knew how to take it apart. We don't get that luxury most of the time. So the trick is, the tough part is to figure out how an equation is built. So we're going to look at some simple examples to help us figure out how how an equation gets built. So let's say we have y minus 3 equals 8. So 8 equals y minus 3. To solve an equation, here's what we do, the steps we go through. The first thing we do is we find the equal sign. We locate that equal sign. Once we locate that equal sign, we identify where the variable is. So here the variable in this one is on the right side over here. So we found where the variable is. Now once we found where the variable is, we have to ask ourselves 2 questions. The first question is, what is keeping the variable, in this case y, I'm just going to say what's keeping y from being alone, from being by itself on that side of the equation? Well, in this case, what's keeping y from being alone? It's the 3, yes. The second equation is, what operation was used to attach it? So there's what operation attaches it. The 3 was built onto the y by doing what? Was it multiplied, divided, added, or subtracted? The 3 was subtracted, right? So now we know this equation was built by subtracting 3. So to take it apart, we have to do the opposite. What's the opposite of subtracting 3? Adding 3. So adding 3 removes that piece, and we're left with y. Now, as we said before, because of that balanced scale, if we add 3 to one side, we have to add 3 to the other side. So we add 3 over here. 8 plus 3 is 11. So we get that 11 equals y, or y equals 11. Now, at this point, if we're not sure, we can always go back and check to see if our answer is correct. To do that, if we say that y equals 11, we can replace y in our original equation with the number 11. So instead of 8 equals y minus 3, 8 equals, we put in 11 minus 3. So this is 8. 11 minus 3 is 8. So we get the same value on both sides of the equation. So that tells us that we most likely did that correctly. We might have an equation that looks like this. 6z equals 24. So again, we find the equal sign. We identify which side has the variable on it. That's over there, 6z. And then we ask our questions. What's keeping z from being alone or being by itself? In this case, it's the 6. What operation was used to attach the 6 to the z? 6 been added, subtracted, multiplied, or divided? The 6 is multiplying the z. So to take it apart, to remove it, we have to do what? Divide. So divide by 6 to remove that 6. Leaves us with z. And of course, we have to do exactly the same thing to the other side. 24 divided by 6 is 4. Again, we can double check. 6 times z is going to become 6 times 4 because we replace z with 4. And we check to see if that equals 24. Well, 6 times 4 is 24. So we get the same value on both sides of that equation. Well, so far we've looked at simple equations, or what we call one-step equations. And the reason they're called one-step equations is there's only one step taken to build them, and there's only one step taken to solve them. This one was built by multiplying by 6. We divided by 6 to solve it. One step. This was built by subtracting 3, so we added 3 to solve it. Again, one step to get to the solution. Most equations are not that simple. So if we run into an equation like this, 5x minus 2 equals 28. We go through the steps, we find our equal sign right there. We identify where the variable is, it's on the right side. And what's keeping that variable from being alone? Well, there's the 5 and the 2. The 5 is attached to the x with what operation? Add, subtract, multiply, or divide?
Multiplication.
The 5 is multiplied. And the 2 is subtracted. Good. Now, if we want to know how this was built, we look at what's been done to the variable. In this case, what's been done to x. According to our order of operations, what do we do first? Would we multiply first or subtract first? Order of operations says multiply first. Good. So when this equation was built, the first thing that was done to the variable is multiplied by 5. And then the 2 was subtracted from it. Now, like I said earlier, if you put something together, whether it's a model or a piece of furniture or whatever, and you've just finished, you've just put on that last piece, if you go to take it apart, what's going to be the first piece you take off? The last piece you put on. So subtracting 2 was the last piece that was built onto this equation. To take it apart, that's the first piece we get rid of. So we get rid of it by adding 2. You have to make sure we do the same thing on the other side of the equal sign. 28 plus 2 is 30. On the right side, we've got rid of the subtracting 2, so all we have left is 5x. And now what do we have to do? Not subtract, but divide by. There we go. The 5 multiplies the x, so we're going to divide by 5. So that 5 is gone, leaving us with x on that side. 30 divided by 5 is 6. And once again, we can double check our answer. Going back up here, 28 equals 5 times x, where we're going to replace x with 6. So 5 times 6 minus 2. And calculate it out. 5 times 6 is 30, minus 2 is 28. So we do get 28 on each side of the equal sign. So here we've got 3y plus 9 equals 36. Now I'm going to stop going through them step by step here and let you guys run loose a little bit. To solve this, in other words, to take this apart, what's the first piece we're going to have to take off? What's the first thing we're going to have to do? Subtract the 9. Good. This equation was built, y was multiplied by 3, and then 9 was added to it. So to take it apart, we reverse that. We subtract the 9 first. That 9 is gone, leaving us with 3y. We have to make sure we subtract the 9 from the other side of the equation as well. So 36 minus 9 is 27. What's the next thing we need to do? Divide by 3. Perfect. So that 3 is gone. We have to divide by 3 on the other side. 27 divided by 3 is 9. So we're going to have you guys try one here. So 2x minus 5 equals 11. I'm going to give you a minute or so to figure out what x equals there. So what's the first thing we have to do to solve this? Add 5. Great. So that's gone. 2x equals 16. Then what? Divide by 2. Perfect. So the 2 is gone. That's x. 16 divided by 2 is 8. Now this next one doesn't look terrible, but it has some things in it, or one thing in it that tends to confuse people. So 11 minus 2x equals 3. When we look at how this was built, what was done to x to build this, a lot of people would look at this and say x was multiplied by 2, and then the 11 is subtracted from it. But that's not true. What has x been multiplied by here? Perfect. It's been multiplied by a negative 2. Now, since this is a positive 11, that 11 is technically has been added to it. Even though it comes out front, it's a positive 11, so the 11 is added. So when we go to solve this, what's the first thing we have to do? Well, we've got the 11 was the last, adding the 11 was the last thing done. So the first thing to remove is the 11, and we do that by subtracting 11. Good. So what's left here is negative 2x. 3 minus 11 gives us what? 3 minus 11 is negative 8. Good. So then to finish this off, what do we have to do? X is being multiplied by negative 2, so we have to divide by, no, still going to divide by a negative 2. So we get rid of that. We divide by negative 2 over here. X equals negative 8 divided by negative 2 is a positive 4. Now, dealing with the negative is the most common mistake made on a problem like this. So let's go back and double check to make sure it works. So 11 minus 2x is going to be 2 times 4 now instead of x equals 3. 2 times 4 makes 8. 11 minus 8 does give us 3. So we get 3 on each side. So we're relatively sure that we have a correct answer there. So how about an equation like this? Now, just looking at this one, a lot of you can probably figure out what value has to go in here for x to make this true. Can anybody tell me what x has to be here? X has to be 5. We know that 7 minus 5 equals 2. But if we were going to try to solve this out formally, the way we would have to look at this, the easiest way to look at this is a negative 1 times x. So now, similar to the last problem, x has been multiplied by negative 1, and then 7 has been added to it. So to solve, I subtract the 7. It's a positive 7, I get rid of it by subtracting. Subtracting 7 over here, 2 minus 7 is a negative 5. What's left on the right side is the negative 1 times x. So to finish solving it, I have to get rid of the negative 1. It multiplies the x, so I get rid of it by dividing. So I divide by negative 1. Negative 5 divided by negative 1 gives me positive 5. Good. The negative 1's divide out there to give me x. So 5 equals x. And as always, we could go back and plug it in for x here to make sure it works. At this point, I'm going to trust that you guys can do that on your own if you want to. When we see an equation like this, we're back to just a single step here. What has been done to x? Well, what's keeping x from being alone is this 2 here. Right? But it's not multiplied by 2. That 2 is a power. So what's been done to x here? X has been taken to the power of 2, or it's been squared, in other words. What's the opposite of a power? A root. So this is to the power of 2, so we have to use a square root. So we have to square root the other side of the equation as well. So the square root of x squared, the root and the squared cancel out, leaving me with x. What's the square root of 16? It's 4, or what's the other one? Careful. Negative 4. So negative 4 could also be a solution, because remember, negative 4 squared is also going to be a positive 16. Now, most of the time, when we're solving an equation, there is a real-life application that goes with it. There's something that's really going on. So most of those real-life examples or applications, the negative is most likely not going to be a realistic solution. But it is still there, and we do have to consider it to make sure that it's not a possibility. We might look at one like this. The third root of x equals 2. So now in this case, x has had the third root taken of it. So if x has been taken to the third root, what's the opposite of a third root? The power of 3, right? Yep, same. I know what you meant. Power of 3. So the power of 3 and the third root cancel out, leaving me with x. What is 2 to the power of 3? Don't say 6. Perfect. 8. 2 to the power of 3 means 3 2's multiplied together, which is 8. X does equal 8. Now these equations can get more complex. We could have 3x squared equals 192. So when we look at this, again, we ask ourselves what's been done to x. Well, order of operations says, right now x has been multiplied and it's been taken to a power. Order of operations says what happens first, the power or the multiplication? The power, right? So the first thing that's been done to x is it has been squared. The second thing that's been done to x is it has been multiplied by 3. So when we go to take this apart, what is the first thing we have to do? We have to divide by 3. Very good. The last thing that was done was multiplying by 3. The opposite is going to be to divide by 3. So that leaves us with x squared here. 192 divided by 3 is going to be 64. Now we have that squared. How do we get rid of the squared? Square root. Very good. So the square root and the squared cancel out. X equals the square root of 64 is 8. Or, of course, what's the other option? Negative 8. Again, for our purposes, we're mostly concerned with the positive result. So what if we have y squared plus 7 equals 16? Again, if you look at how this equation was put together, in this case, what's been done to y, there's a power, and then the 7 has been added. What order of operation says what happens first? Is it a power or is it adding? Power. So it's been squared first. And then adding 7 is the last thing that was done to build it. So to take it apart, we reverse that. What's the first thing we do to take it apart? Subtract the 7. Good. So that 7's gone. We've got y squared equals 16 minus 7 is 9. Then what? We square root it. Get rid of the squares. So the squared and the square root go away. Y equals 3 or negative 3, of course, for our answer. What does this mean? Well, the parentheses tell us that when this was built, what happened first? Well, when this was built, 2 was added to x first. Then it was squared. So the parentheses, remember, parentheses are our highest priority in our order of operations. So what has to be done first is what's in the parentheses. So when this was built, the adding 2 happened first, and then the squaring happened after that. So when we go to take this apart, we have to square root first, because squaring was the last thing that was done. So we square root. So the squared and the square root cancel out. What's left over here is x plus 2. What's the square root of 25? 5. Now, right now, we're going to just go with the positive result of the square root. Technically, as we said, it's 5 or negative 5. And if this were a formal college algebra class, we would have to solve the x plus 2 equals 5 and the x plus 2 equals negative 5. We'd have to solve 2 equations to get 2 different answers. For now, we're not worried about that negative part. We're just going to deal with the positive 5. So what do we do to finish solving this? Perfect. We subtract 2. So that 2 is gone. X is equal to 3. Any questions? Okay. So let's take one that's, well, let's see just how bad we can make this. 2x minus 5 squared oops. Oh, let's see. 3 squared is 9, 27, 25. So looking at this one, this is a pretty ugly looking one. There's been a lot of things done to x here. We see that parentheses, and we want to do something there first. But there's nothing that we can do inside those parentheses. 2x minus 5 cannot be combined. We want to do the times 3, but we can't because the parentheses has been squared. Now, if we really wanted to, we could do the 2x minus 5 squared, but that would make this really a tough problem to do, so we're not going to do that. But let's just look at what's been done to x. Let's leave it as it is and look at how this equation was built. So here's x. If x were a number, what's the first thing that would have to happen? Obviously, we're inside the parentheses. Would we multiply it by 2 or would we subtract the 5? It'd be multiplied by the 2, right? Because multiplication, order of operations says multiplication happens before subtraction. So x would be multiplied by 2, then the 5 would be subtracted. So that's everything in the parentheses. Next would be the squared, because that power, the exponent, has to happen before multiplication. Once we square this, then it is multiplied by 3. Then the 2 is subtracted. When we go to solve this, of course, we have to reverse that process. The first piece we take off is the last one put on. So what's the first thing we're going to do? Well, not subtract 2, but add 2. Very good. Gets rid of the subtracting 2. So we add 2 over there. That's 27. Over here, the minus 2 is gone. So this is 3 times 2x minus 5, and that's squared. The next thing we have to get rid of, multiplying by 3, and we're going to do that by the opposite of multiplying is dividing by 3. So that's gone. We've got 2x minus 5 squared. 27 divided by 3 is 9. The next thing we have to get rid of is the squared. We'll do that by doing a square root. The square root and the squared cancel out. 2x minus 5 equals, what's the square root of 9? 3. Again, 3 or negative 3, but we're going to just use the positive. Now, from this form, you guys should see how to solve it the rest of the day. What's the next thing I have to do? Add 5. So 2x equals 8. And finally, divide by 2. X equals 4. Okay, it's about that time, so let's go ahead and take a quick break. It's about 2:46 here, so let's come back at 2:49. Okay, so we've seen some of those tough equations with powers and roots. Let's take a look at some other things that can be used to complicate these equations. One of them is going to look something like this. So when we go to solve this, as always, we find our equal sign and we identify where the variable is. And the variable here is on the left side. But when we do that, we notice that the x appears twice. So now when the x appears more than once like that, there are 2 possibilities. Well, technically 3 possibilities. But the first possibility is that the x's are on the same side. And that's what's the case here. The x's are on the same side. If we're thinking of that idea of a balanced scale, we have 5x and 2x on the same side of that scale. Are we able to just push them together? If we pushed them together and made one big pile, like 5x and 2x make 7x, would that change how this scale balances? Well, no, it wouldn't, because they started out on the same side. We could just combine them, and it won't change anything. So 5x and 2x make 7x. We still have the plus 3 there. So 7x plus 3 equals 24. And now we can go ahead and solve this like we have with any of the others. What would we do next? Subtract the 3. Perfect. So that's gone. We have 7x equals 24 minus 3 is 21. And the final step? Divide by 7. Good. 7's gone. X equals 21 divided by 7 is 3. Good. Yay. So now we've got x equals 3. Just like always, we can go back and double check to see if this works out by replacing x everywhere it appears with a 3. So 5x becomes 5 times 3. Plus, we just had a regular 3 there. Plus 2x becomes 2 times 3. And we have to see if that comes out to be 24. So we have 5 times 3 is 15. 2 times 3 here is 6. 15 plus 3 is 18. Plus 6 is 24. So 24, we get 24 on both sides. So that indicates that that most likely is the correct answer. So if the x appears twice, but both of them are on the same side of the equation, we can just combine those. 5x and 2x made 7x. This one, when we go to solve it, we find the equal sign right here, but we go to identify where the variable is, and we see this time not only does the variable appear twice, but it's once on each side of the equation. Since it's on each side, that's our second case, it's on both sides of the equation. When it's on both sides, we can't just push them together. We can't just combine them anymore. So we have to get rid of one of them. Generally, we get rid of the smaller one. So we're going to remove the smaller one. And mathematically, the way we remove something is we subtract it. So here, the smaller one between 5x and 2x is the 2x. We're going to subtract it. We're going to take away 2x. It's gone. That leaves us with 21 on the right side. Now we still have to take 2x away from the left side. The only place we can take it away is from the 5x. Because remember, when we add or subtract, we can only combine things that have the same name. So we can only take 2x away from other x's. 5x minus 2x is 3x. What else are we missing over here yet? We still have to have the plus 3. Good. And now, of course, we can solve this equation by doing what? We subtract 3 from both sides exactly. So 3x equals 21 minus 3 is 18. And finally, we divide by 3. Good. So x equals 18, not 18. 18 divided by 3 is 6. X equals 6. So when we have the variable appearing more than once, either it both appears on the same side, and we can just combine them like we did here, or it appears on both sides, and we have to get rid of one of them. Stick with me, gentlemen. So we've got to be careful. We can have one like this. 9 minus 4x equals let's see, a negative 15. Let's do this. 2x minus 15. So here when we go to solve this, we find our equal sign here. And we notice that the x again appears on each side. So we're going to have to get rid of one. And like we said, we get rid of the smaller one. Which one is smaller here?
2x. -4.
Careful, -4 is smaller. Now we said we get rid of them by subtracting it. But since this is a -4x, how would we get rid of it?
Add 4x.
We're going to add 4x. Good. Since that's a -4x, adding 4x takes that back to 0. So we're left with just 9 over there. So then we have to add 4x on the other side. So 2x,
6x.
perfect. 2x plus 4x is 6x. And we still have the -15. So now what do we do? Add 15. Good. So 9 plus 15 is 24 equals 6x. Then what?
Divide by 6.
We divide by 6. So 4 equals x. Good job. Got to be careful here. Got to make this solvable. Okay. So looking at this one, we have, here's our equal sign. And in this one, the variable appears 4 times. Well, just like we did before, we're going to work with combining what we can on each side. So what we can do here is we can actually look at the left side and the right side as separate problems at first. So let's look at the left side here. What can we combine on the left side?
5x and -2x.
Perfect. 5x and -2x, which make what? 3x. And of course, we still have the +7. So the left side of that equation combines to make 3x plus 7. On the other side, we have 3x and -2x, which make 3 and -2 make 1. So that's 1x or just x. Remember we talked about that, just like if you say an inch, you can say 1 inch or just an inch. 1x or just x mean the same thing. And of course, we still have the +15 there. Now we still have an x on each side, so we have to get rid of 1. It might be easier to think of that still as being a 1x. So what are we going to do to get rid of 1 here?
Subtract 1x.
We're going to subtract 1x. So that's gone. We just have 15 on the right side. We subtract 1x on the left side, which leaves us with 2x. And we still have the +7. Good job. Now what? What's next?
Subtract 7.
We subtract 7. Good. We subtract that 7. So we're left with 2x over there. 15 minus 7 is 8. And finally,
Divide by 2.
divide by 2.
X equals 4.
Perfect. X equals 4 again. Apparently I'm stuck in a rut on x equals 4.
I guess so, huh?
Oh well. So anyway, our next step is to look at problems like this. What's different about this one that we haven't seen before? Parentheses. And as we've said before, anytime we see parentheses, it should scream at us, do something here first. And we have those 2 questions. Is there anything to do inside those parentheses? No, we can't. 5x minus 3 cannot be combined.
Yeah, you can't do that.
So then the next thing is there anything that needs to be done to the parentheses? It's multiplied by the 3. So you got it. 3 times 5x is 15x. And what's next?
3 times -3 is -9.
Perfect. 3 times -3 is a -9. So 15x minus 9 equals 21.
Then we got add 9.
Then we add 9. Good. So 15x equals 30. And then?
Divide by 15.
So divide by 15. X equals 2. Good. So for this one, what do we have to do here first? Tell me where to start.
So you're going to do 2 times 7. Yeah, 14x.
2 times 7x is 14x. 2 times 4 is 8. Good. So 78 equals 14x plus 8. Then what? Subtract the 8. So 70 equals 14x. And then divide by 14. X equals. Okay. 70 divided by 14 is 5. Okay, so here we've got a couple of things to consider. We still have parentheses, so that still should draw us in to do something there first. So what are we going to do to start this one?
5 times 2x.
Yep, we're going to distribute the 5. So 5 times 2x is
10x.
10x. What's next?
5 times -3 is -15.
Perfect. 5 times -3 is -15. Now we still have the -2x over here. What's our next step?
Add 15. No, you can combine the 10x and the -2x.
Perfect. We have to combine still the 10x and -2x make 10x and -2x make 8x. Somebody get a little too much Mountain Dew for lunch today? Okay, so now what's our next step here?
Add 15.
Adding 15. 8x equals 48. And finally, divide by 8. X equals 6. Well, when you have, before you start doing the solving, before you solve and start taking it apart, you have to get it down to where the variable only appears once. So you have to get, parentheses have to happen first, then you have to combine any variables that you can, and then you start to solve.
I got you.
Okay, you bet. So when we look at this one, we see we've got parentheses on each side. So where do we start? Well, we've got parentheses on each side. So what we can do is we can actually as we said before, we can separate each side and work with each side separately. So I'm going to start by working on the left side. So I have these parentheses over here. I'm going to go ahead and multiply by the 2. So 2 times 7, there you go. 2 times 7x is 14x. 2 times negative 4 is negative 8. Now we still have the negative 3. Now before I do anything on the right side, I'm going to finish combining this. What else can I combine here? Perfect. So the 14x doesn't change. Negative 8 and negative 3 make negative 11. So now on the right side, what do I have to do first?
3 times 2x is 6x.
Perfect. 3 times 2x is 6x.
And
3 times 1 is 3. Now we still have the minus 1 over there. 6x, yes. So we combine the 3 and negative 1, make a positive 2. Now we still have the x still appears twice, so we still have to get rid of one of them before doing anything else. So we are going to
subtract 6x.
perfect. Subtract 6x to get rid of it. That leaves us 2 on the right side. Subtracting 6x over here gives us 8x. We still have the minus 11. Now what do we do? Add 11. So 8x equals 13. And then divide by 8. What's that give us?
1.625.
Okay, if we divide it out in the calculator, we get 1.625. How did I get 1 5/8? Well, this is a division problem. Remember, we said there's a relationship between a division problem and a fraction. 13 divided by 8, I can treat that just as though it's 13/8. 8 goes into 13 once with 5 left over. So 1 5/8. So either one of those would be acceptable. For construction, 1 5/8 is on the tape measure. 1.625, you'd have to convert it to a fraction anyway. So what are we going to do here? Well, we have our equal sign right here. So I can work on each side again. On the left side, what am I going to do first?
5 times 2x.
5 times 2x, which is
10x.
10x. Then 5 times negative 3 is negative 15. Perfect. Now the second parentheses here is being multiplied by what?
Negative 3.
A negative 3. Good. We can't miss the negative. So negative 3 times 5x is
Negative 15.
negative 15x. Negative 3 times 1 is
Negative 3.
negative 3. So now we're still going to work on the left side. What more can we combine on the left side over here?
The 10x and the 15x.
10x and negative 15x, which make what? Yeah, 10 and negative 15 do make negative 5. So now I've got negative 15 and negative 3, which make negative 18. So the left side becomes negative 5x minus 18. What do we do on the right side?
2 times 4.
2 times 4x is 8x. Good.
Negative 6.
2 times negative 3 is negative 6.
Plus the 7x.
Plus the 7x. Okay, what's next?
Combine 8x and 7x, which is 15x.
15x, good. 8 and 7 make 15x, minus the 6 still. Now we still have an x appearing twice. We need to do what?
Add 5x.
Perfect. Negative 5x is the smaller one, so we add 5x. So 15x plus 5x is 20x, minus 6. Over here we still have negative 18. What's next?
Add 6.
Add the 6. Good. So that's gone. We have 20x over here. What is negative 18 plus 6? Negative 12. Wonderful. And our last step?
Divide by 20.
Divide by 20. Good. Negative 12 divided by 20 is negative 0.6 equals x. Any questions? Okay. One last example I want to do, and then I'm going to give you guys some homework. Better than a quiz? There you go. There's a bright side to everything. So looking at this, again, here's our equal sign. So I'm going to work on the left side and combine everything I can combine over there first. So on the left side, where do I start?
2 times 5x, which is 10x.
Perfect. 2 times 5x makes 10x. And then?
2 times negative 1, which is 2.
Perfect. 2 times negative 1 is negative 2. Now this second set of parentheses is where we have to be careful. What is multiplying this second set of parentheses?
Just a negative.
Just a negative. And what we're going to do is we're going to make it a negative 1. So it's a negative 1 times 3x, which is negative 3x. Negative 1 times 1 is negative 1. Perfect. Now, what can we still combine on the left side? Stick with me, guys. Just got a few minutes longer. What can we still combine on the left side?
10x and a 3x.
10x and negative 3 make 7x. Negative 2 and negative 1?
Negative 3.
Negative 3. Very good. So 7x minus 3. So now that's everything. That's all we can do on the left side. We go over to the right side. Where do we start?
4 times 3
Which is?
is 12.
It's 12x. 4 times negative 7? It's negative 28. So now we still have the plus 2x and the minus 1 over there. So what's next?
12 plus 2x. Or 12x plus 2x.
12x plus 2x makes
14x.
14x. And
Negative 29.
negative 28, negative 1 do make negative 29. Now what?
Subtract 7.
Yep, you have it right. Exactly right. We have an x on each side, so get rid of the smaller one. Subtract 7x. So over here we have negative 3. 14x minus 7x is 7x minus 29. Now what? We add 29. Very good. What's negative 3 plus 29? 26. Good. And their last step? Divide by 7. So x equals 3.7142857 approximately. Or if we wanted to leave that as a fraction, 26 divided by 7, we treat that as 26. It's 26 over 7. 7 goes into 26 3 times with 5 left over, so 3 and 5/7. See, somebody asked, why is that not 32? Because it's negative 3. Okay. So you got negative 3 and positive 29. Perfect. Okay, now these are going to be coming out of your big book, and there's a lot of pages here. So in the big book, we're going to be looking at page 368. This is exercise 14-5. Do all the odds there. On page 370 through 372, this is exercise 14-6. This is problem solving using these equations. So do the odds there. Page 373 through 374. That's exercise 14-7. Page 375 through 377. Exercise 14-8. That again is problem solving using these equations. Page, come on. There we go. Page 378 is exercise 14-9. That's solving equations with powers. And page 380 is going to be exercise 14-10. That's solving equations with roots. So that's a lot of problems to work on. Just as always, make sure you do a few problems off of each section, but be sure you know how to do it. Friday, there will be a quiz on solving these basic equations. So make sure you're ready for that. I will let you guys have the last 11 minutes here to go ahead and get started on your homework.